Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Let us see today's overview of the course. In the previous session, we have discussed about what are the different types of graph traversals. In that, we have already covered what is BFS, Breadth First Search Traversal. In this session, we will be discussing about DFS, that is Depth First Search Traversal, and in this we are going to see one of the example for DFS. Okay, let us see what we are going to have in DFS. It will be similarly like BFS, but here the same thing, but it is little bit differed with the BFS. What is the difference we are going to have? That one we will see here. DFS, the same thing. The DFS of a graph produces a spanning tree as a final result. And the spanning tree is nothing but a graph without loops we are going to have. And here the data structure which one we are going to use in DFS is the stack data structure. And the stack size we are going to define based on the maximum number of vertices that was present in the graph. Right. Now you can see here, these are the steps where you are going to follow in DFS. The first thing, you are going to define the size of stack. You can select any vertex as the starting point of the traversal, visit the vertex and push it onto the stack. Previously, we have used Q, right? That's why we have given insert or NQ, that names we can use, right? And here, if any one of the non-visited adjacent vertices of the vertex, which is at the top of the stack, and push it onto the stack. In the previous case, we have inserted all the adjacent vertices into the queue, but here we can select any of the non-visited adjacent vertex. Only one vertex we can insert or pushed onto the top of the stack. This one you have to remember. Only one vertex we need to push it onto the stack, and that to be non-visited. And repeat step 3 until there is no new vertex to be visited from the vertex which is at the top of the stack, right? Until you find no new vertex to be visited, until that you have to repeat this process. When there is a new vertex to visit them, use backtracking and pop one of the vertex from the stack, right? If you don't find any new vertex, then again we need to come back, and from there we need to backtrack our visiting, right? And in that case, we need to pop that vertex from the stack. When you are backtracking, you have to remove that vertex from the stack, and then we need to move again. Repeat these steps and 3, 4, 5 until stack becomes empty. In this case also, the stack has to become empty. Until that, we have to repeat this process. When stack becomes empty, then produce the final spanning tree by removing unused edges from the graph. The same thing. And here the main thing is the backtracking is one coming back to vertex from which we reached the current vertex. When you are backtracking, you have to reach the current vertex, and from there can we move to the other vertices or not, which are not visited. That one we need to check. That is the main purpose of the backtracking here. Now let us see the example for DFS traversal. The same graph which I have taken in the previous example. Here also we are going to select the same vertex A as the starting vertex. From there you have the adjacent vertices are B, D and E. But I have selected B as the next adjacent vertex. When I have visited that vertex, push it onto the stack. And then I have selected B, so that I am going to push it onto the stack. Next, again from B, the adjacent vertices are A, E and C. In that A is already visited and E and C are there. I have selected C as the adjacent vertex and I have pushed it onto the stack. Next, from there I am going to select C, and then after C I have selected E, F and G are there adjacent vertices, but I have selected E and pushed onto the stack. And the next one we have from D, I am selecting the vertex D, right, push it onto the stack. We have E and F and G also, but I have selected D to show you how the backtracking will be. Right. And from D, is there any unvisited vertices we have? No, all the vertices are visited. Any new vertex we have to visit? Yes. But here we still not finished our all the vertices are visited. We are left with F and G. So what we need to do is we need to come back from where you have moved to D, from where you have moved from E to D. So that what we are going to do is we are going to remove D and we are coming back to E. So that you could observe here, you are in D is on the top of the stack. After removing D, you are coming here. Previously it was D. Now we are coming back to E. Now from E, we have some unvisited vertices, and those are adjacent for E. So that we are going to push that onto the stack. So we are going to push F onto the top of the stack. After pushing F onto the stack, again check for any adjacent vertices which are not visited. G is not visited, so we are going to push it onto the stack. And from there you check, is there any new vertex to be visited from G? No. So use backtrack and pop G from stack. From G you are coming to F. Pop it from the stack. Next, from F, is there any new vertex to be visited? No. So you backtrack it. From F you are coming back to E, right? And from F, is there any new vertex to be visited? No new vertex to be visited. So backtrack to E. So that you are going to backtrack to E, right? This is done. This is already done. And from E you don't have any new vertex to be visited, so we need to come back to C. And from C, we don't have any vertex to be visited, new vertex, so we need to come back to B. And from B, you don't have any vertex to be visited, you have to come back to A. And A is already visited, right? There is no new vertex to be visited from A, so use backtrack and pop A from the stack. We are going to pop it from the stack, and now your stack becomes empty. Now stop your DFS traversal, and final result of DFS is the following spanning tree. How the path you have selected, right? The same path we are going to represent. This is your DFS traversal. And I hope you understand this. And the overall summary of this DFS is, we have seen what is DFS and what is the resultant graph which you need to get it from the DFS. That means overall we need to get a spanning tree without forming any loops. And here we are going to use the backtracking. When you are compared with the BFS and DFS, in BFS we are not using any backtracking, and in DFS we are going to use the backtracking method. Okay, and we have seen one of the example of DFS also. Okay, that's all. This is the session, and thank you. If you have any queries regarding this session, you can do comment in the comment section.